So Heisenberg's uncertainty principle. A moving particle is associated with a de Broglie wave group. So it is better to represent it by a group of waves rather than by localized entity. So there is a fundamental limit to the accuracy with which we can measure the properties of the particle, such as its momentum and position. When de Broglie wave group is very narrow, the position of the particle can be easily estimated within the width of the group. The wavelength is very hard to establish if the width of the group is wide, and then the wavelength is can be easily established by the particle may be anywhere within the wide width of the. So basically, here the particle can be established by the wavelength, and here the wavelength can be established by the particle. Thus, there is always an uncertainty in the simultaneous measurement of the momentum and the position of the particle. Momentum is dependent on this lambda, so that's the reason. The uncertainty principle states that the product of the uncertainty delta x in the position of the body at some instant and uncertainty delta p in its momentum at the same instant is equal to or greater than equal to h by 2 pi. The reduced Planck constant h dash, h being the Planck constant I. So if we so let's write this down. Del x del p is greater than h 2 pi. Now let us consider two wave trains of slightly different angular frequency and propagation constant that are superimposed to form a group of waves. So we have got this is A cos omega t minus kx, and this 2 is A cos omega plus omega t del omega t del omega t minus A plus del k of x super superposition of these two waves gives this just plus this, which is 2a cos half times 2 omega plus del omega t minus half times 2k plus del kx. This entire thing into cos half del wt minus del kx. Okay, I think this is the formula. This is some first the formula we have used. Since omega is k, so this can I think be written as, so this is then directly considerable omega t by okay. Yeah, and this is just put inside. This cos 2 theta, cos 2 of theta is cos 2 alpha plus theta, cos alpha by 2 plus theta. Like this. Okay. I think you can do that. Of each group is equal to the half the wavelength lambda width of each. We assume that the uncertainty delta x, the width of each groove, is half the lambda and the. So we assume that the uncertainty delta is equal to the width of each groove. So delta x is what? Uh, multiplication constant of the modulus. Uncertainty delta. Okay, the deformation constant. Uncertainty particles. Okay. I think I need a break for this. So let's let's first unit B now. I will go on to stop this scene. Go on to this.